15 and construct the understanding. First of all, I named all of these. I called this one g of x, I called this one f of x, and I called this one h of x. I asked you to do the synthetic division for all three of them. And then once I had the synthetic division for all three of them, I wrote out the division statements for all three as well. And I called them different things because they're different equations. Now the construct the understanding said, once you've figured out your division statement, and you've done the synthetic division, you're able to see the remainders, okay? And I hope that you notice that the blue one and the black one, they factored perfectly because there was a remainder of 0. But the green one doesn't factor perfectly because it had a remainder of 4. This question also then wanted you to do the following. Figure out what g of 1 is, what f of 3 was equal to, and what h of negative 2 is equal to. And here's something that's interesting. If you plugged 1 in for x into this first equation, you would get 0.
Hi there.
Hello.
Can I have Sir John to the office for a moment?
Yeah, he'll be right down.
Thank you.
When you plug 3 into this equation, it's going to be a little bit of mental math to do. 3 times 27 minus 8 times 9 minus 3 minus 2. You get 4. And when I plug in negative 2 into x for this one, lots of mental math to do, you get 0. And there is a beautiful pattern that starts to show up. And it's actually easy to see why this pattern works if we've done the division statement. Do you notice that when I plugged in 1, I got 0, which was the remainder of the blue one? When I plugged in 3, I got 4, which was the remainder of the green one. And when I plugged in negative 2, I got 0, which was the remainder of the black one. So plugging in the number that would make the divisor equal to 0 gives us the remainder. And seeing why this works is so simple when you look at the division statement. Let's look at the green one, because it's the nicest one, because it's the only one that has a remainder. The green one has a remainder of 4. Does it make sense that when I plug in 3, and it's written in this factored form, what's 3 minus 3? 0. Doesn't matter what this is. This whole thing is going to be 0 when I plug that in. And what is the only thing I'd be left with then is the remainder. Same thing here. When I plug in 1, this first factor is going to equal 0. So the only thing that would be left is the remainder. And if there are no remainders, then it's going to equal 0. Being able to do this is called the remainder theorem. And it's at the bottom of your next page. It says when you're dividing by x minus anything, if you plug that into your original polynomial, the answer that you get is equal to the remainder. And the division statement explains why this happens. Because your division statement and if your divisor is x minus a and you plug in a, this part will always equal 0. And 0 times the quotient will still be 0, and you will just get the remainder that's left. Now the remainder theorem is going to be important for us because it's going to help us figure out how to factor. The next stage that we're looking at in this unit is how we can use synthetic division, long division, and our knowledge of equations to help us factor. So right now, look at this. We factored the first one. The first one you could have factored using your old school methods. It's a quadratic. You could have just factored that one directly. But the last one, we started to factor the last one. We found out that x plus 2 was one of the factors because when you plug in negative 2, you would have no remainder. So this is our remainder theorem. And you will get questions that just say, hey, can you find the remainder when you divide by each binomial? And if it's asking you to find the remainder, you now have two techniques, well actually three techniques to find it. You could use long division and find the remainder. You could use synthetic division and find the remainder, or you could use the remainder theorem. And sometimes one is better than the other. So we're going to look at part A here. We're going to determine the remainder when I'm going to go let P of x equal all of this is divided by x minus 3. So since we just learned the remainder theorem, I'm going to start with the remainder theorem. The remainder theorem says if I plug in 3, because I'm dividing by x minus 3, I will get the remainder. What does this mean? That means wherever there was an x, I plug in a 3. I simplify each of these. Exponents first. 3 to the 4 is 81 times 2 is 162. 3 cubed is 27 times by 5 minus 135. 3 squared is 9 times negative 5, negative 45, plus 15, plus 3. And that's equal to 0. So we could find the remainder by just plugging in 3 in for x. We could also find the remainder, I'll do this in blue, all right, or, okay, with long division or synthetic division, and if you can use synthetic division, I hope you realize that that's faster than long division. We're dividing by x minus 3, so I would be able to use synthetic division. I put a 3 out there. My coefficients are 2, minus 5, plus 5, and 3. I double checked that they were in the right order, and I didn't have to add any zeros. Again, synthetic division says bring down the 2, multiply, add, multiply, add, multiply, add, and multiply, add. There's our remainder of 0 using synthetic division. If you would say, which method is better in this example? I would probably say the synthetic division was less mental math, okay? Mental math. What is the biggest multiplications I had to do in the top one? I had to multiply 27 times 5. I had to do 3 to the 4 in my head and get 81 and times that by 2, 162, okay? So as far as multiplication goes, I had 27 times 5. What's the biggest multiplication we had here? Ooh, 3 times negative 2. Intense. See how much smaller the multiplication was here compared to plugging it in? Adding and subtracting, just a little comparison. Here I had to add and subtract 162 minus 135 minus 45 plus 15 plus 3. Not crazy hard, but a little bit of mental math. Here, I think minus 5 plus 3 was the hardest adding. Again, I hope you realize that the adding in the synthetic division in this case was a lot easier. So So both of them get a remainder. I'm going to leave part B for you. Your homework on this question are 4A, 6A, 7, and 8.